we're going to calculate the pH of a basic solution here. Anytime you see molarity and something after it, you know it's dissolved in water. It's very, very, very unusual to use molarity when the solvent is not water. So that's something we've been taking for granted, but I need to say. Then we should notice that this is a strong base. Again, group 1 and 2 hydroxides are strong, except for beryllium hydroxide and magnesium hydroxide. It needs to be on your list. If it wasn't strong, and same with an acid, then you're going to have an equilibrium problem with a Rice table and stuff like that, which we will do. But anyway, since it's strong, we know that when you put it in water, it's going to completely ionize. Okay. And so we should notice that for every one of these, we get 2 hydroxides. That means that our hydroxide ion concentration is 2 times the calcium hydroxide ion concentration. Well, to get pH, we need to know the hydrogen ion concentration, not the hydroxide. But we have a way to get between those two. We know that we're going to use the Kw. We know that for aqueous solutions, this is always true, assuming 25 degrees C. It changes a little bit with temperature because it is an equilibrium constant. So we can plug into this. Okay, and then almost finished. Then we can use the definition of pH. pH I'm about out of room there, but let's look at a few things. First of all, our sig figs. We had 2 sig figs. I kind of kept track. 2 sig figs, and that's correct that these numbers in front, it doesn't matter how many, they don't count on a pH. So this does have 2 sig figs, so that's good. So it is one of those things where it looks like you gained sig figs, but you really didn't. The other thing we can check is say, well, is this the number we would expect? And again, if you use the exponent of the hydrogen ion concentration, your pH should be within 1 of that, and it is. And then the last thing is, do we expect a high pH? This is over 7, and we do because this is a base. Let's go ahead and do another problem, this time involving an acid. This time we were given the pH and asked to find the hydrogen ion concentration. So it's a little backwards from what we've been doing. We just need to solve the equation the other way. The first thing I'm going to do is multiply both sides by -1 so that I can move my negative sign essentially over to here. leaving a little room for my next step. And then to get rid of the log, what I do is I take the inverse log of both sides. This is like saying 10 to the x is the inverse log. And that gets rid of the log on one side. Okay, and so there we are on sig figs. Already wrote it up here. This just had 2 sig figs because we don't count that front digit on a pH as a sig fig. So I have 2 there as well. And then this next question, we just have to remember this is hydrochloric acid. It totally ionizes. And so I know that there's a 1-to-1 mole ratio. And so I know it's the same number. And by the way, it's still called this concentration of HCl, even though we know that the HCl is actually all in these forms in the solution.